Hey guys, it's Spiral Review for Spiral 26, the last spiral of the year. First off, we're going to talk about right triangle trigonometry, and we're going to look at an angle, and this should be a phi, I don't know why it's a beta, between 0 and 90, and we have cosecant of that angle is the square root of 51 over 2. What I'm going to do with this is set up a triangle. Okay, and the only reason I have between 0 and 90 is because we can have angles bigger than that, as you now know. So if this is angle phi, cosecant goes with sine. That's a terrible sign. There we go. So we're looking for the reciprocal of sine, in other words, hypotenuse over opposite. So square root of 51 can be my hypotenuse. Opposite could be 2. To get this third side, I'm going to do the square root of 51 squared minus 2 squared is equal to the adjacent squared. And that's going to end up being 47 is a squared. So the square root of 47 is going to be a, which is totally lovely and not at all a gross number. Sine can be written as the 2 over the square root of 51, which, by the way, if you want to rationalize that denominator, it would be 2 square roots of 51 over 51. Cotangent of phi, so that's the reciprocal of tangent. Tangent would be 2 over square root of 47, so cotangent would be the square root of 47 over 2. Cosine of 90 minus phi, so to get 90 minus phi, we're really talking about this other angle. And that's because the two acute angles in a right triangle have to add up to 90. So if one of them is phi, the other one has to be 90 minus phi. Cosine of this angle would be 2 over square root of 51. Or, if you want to rationalize that denominator, 2 square roots of 51 over 51. Tangent of 90 minus phi, again, we're talking about this angle. So opposite divided by adjacent would be the square root of 47 over 2. I'd like you to notice cosine of 90 minus phi and sine of phi were the same thing. Tangent of 90 minus phi and cotangent of phi are the same thing. Next one, ooh, this is fun. Find the angle that the straight line y equals 2/3 x plus 1 forms with the x-axis in the second quadrant. Let's draw this. So we're going 1 up, and this angle is going to go at a 2/3 slope. So that's going to be down 1, 2, 1, 2, 3, and this would be at a point -3, -1. What would be nice is if I knew this point. And I could figure out that point. So if the slope is 2/3, that means it goes up 2/3 for each one it goes over. That doesn't really help me. But then I know the y here is 0, so I could plug this in. So 0 equals 2/3 x plus 1. Nice. And I can solve this to find the y-intercept, so minus 1 to both sides, equals 2/3 x. If I times 3 and divide by 2, we get negative 3 over 2 is equal to x. This point is going to be negative 3 over 2, comma 0. And we say that was 0, 1. Hey, this makes a triangle. And if we're looking for the angle in the second quadrant, we're talking about this guy right here. If I were to blow this triangle up, this would be a length of 3/2. This would be a height of 1, and that's the angle that we're looking for. This is going to be opposite and adjacent compared to that angle. So I could say that tangent of theta is equal to 1 over 3 over 2. If I were to do the inverse of this, so tangent inverse of this, which, by the way, 1 over 3 over 2 is the same as 2/3, that's a reciprocal. tangent inverse of 2/3. Gonna make sure I'm in degrees. Second quit. Tangent inverse of 2/3. This is going to be a 33.69 degree angle, which I think is pretty cool. That's a really cool question. I bet you're going to have one very much like it on your spiral. All right, for our last question, we got a 10-mile pathway perpendicular to the beach. First person runs with perfect accuracy, so they're going 10 miles to the beach. The second person misses this path, and they are 1 degree to the right. That's upside down, but that's okay. We're going to make an assumption that the space on the beach is going to be pretty much linear. And what's going to happen is this perpendicular path turns this into a right triangle. How far apart are the endpoints of the runner's path? So what we're really talking about is how far apart are these 2 points. And based on this 1 degree angle, this is going to be the opposite. We have the adjacent. So I can use some tangent for this. So tangent of 1 is equal to the opposite divided by 10. To get that by itself, I'm going to multiply both sides by 10. 10 tangent of 1 is 0.1745 miles. If you're curious about this, so 5,280 is the number of feet in a mile. That's 921.63 feet. How much further did the second runner run than the first runner due to the inaccuracy of the path? So what we're talking about is this path up here, in other words, the hypotenuse. I could do a similar thing. This time I could set up cosine of 1 degree is equal to 10 over h. And if I multiply by h and divide by cosine of 1, we get 10 divided by cosine of 1 degree is equal to h. If I do that out, we get h is equal to 10.0015 miles. So 0.0015 miles would be the total extra distance. And if I wanted to figure out how many feet that was, again, I'm going to multiply that by 5,280. And that's a total of 7.92, or about 8 feet, which is not a heck of a lot. Now we're working with laws of sines and cosines. I've got to solve some triangles. Let's draw these guys first. Okay, so we've got A, B, C. Angle C is 71. Side B is 24. And side C is 31. Okay, I do not have information that would let me treat this using law of cosines. In fact, I've got a nice law of sines relationship going on here by having the opposite pieces. So I might start by saying sine 71 over 31 is equal to sine B over 24. Okay, let's try this out. So sine 71 over 31. I get 0.0305. I'm going to multiply that by 24 to get sine B. Times 24. And I get sine B is equal to 0.73201. Inverse sine that, 0.73201. We get B is equal to 47.055 degrees. Just for the sake of easiness, let's call this 47.06. Okay, third angle 180 minus 71 minus 47.06 will give you my third angle, which is going to be 61.94. To get this last side, I'm going to take this expression, do sine 71 over 31. is equal to sine of 61.94 divide by, I'm looking for a, it's a little a. We've already done the calculation on the left side. That was 0.0305. I've got to multiply both sides by a to get the a by itself, and that's going to be sine of 61.94. Sine of 61.94 is 0.8825. Dividing both sides by 0.0305, we get a is equal to 0.8825 divided by 0.0305, 28.934. So a is 28.9 based on nearest tenth. Next up, we got another law of sines or cosines. I'd probably bet this is going to be law of cosines since the first one was law of sines, but I'm not going to guarantee it. This is FDE, and it looks like we've got measure of F is 89, D is going to be 28 inches, and E is going to be 16 inches. Nothing in opposite pair here. So this is going to be law of cosines. I'm going to try to find F first because that's the angle I've got. And doing that, we got F squared is equal to 16 squared plus 28 squared minus 2 times 16 times 28 times cosine of 89. I'm going to literally type that into my calculator. And we've got 16 squared plus 28 squared minus 2 times 16 times 28 times cosine of 89. And I get 1024.36. When I take the square root of that, we get that F is equal to 32.005. I'm going to leave that as 32. I've got to find at least one more angle before I can do much of anything with this. And for that, we're probably going to use law of sines, just because it's a little bit easier to work with to find angles. And I might find, I don't know, D using F as a pair. So sine of 89 over 32 is equal to sine of D over 28. Doing that out, sine of 89 divide by 32 times 28 gives me 0.8748 equals sine D. Taking the inverse sine of both sides to get D by itself, we get that D is equal to 0.8748, 61.021 degrees. And given that angle, if I do 180 subtracting those two guys, so we got 180 minus 61.021 minus 89 is 29.979. How about we just call that third angle 30 degrees? Next up, we've got a new art installation going downtown with a triangular canvas. The sides are 25, 26, and 27. So I'm going to draw this. 25, 26, 27. I've got to calculate the angles needed for each corner of the frame. I can't assume this is a right triangle. I'm going to call this ABC. Actually, I'm going to call this ART for art. I like that. And to calculate angles, we'll probably need to use law of cosines since we don't have any angles already. I might start with A for that. And we get 26 squared is equal to 25 squared plus 27 squared minus 2 times 25 times 27 times cosine of A. As I start to calculate these things, 26 squared is going to be 676. 25 squared plus 27 squared plus 27 squared is going to be 1354. 2 times 25 times 27 is going to be 1350, and I've still got a cosine A. Since we have a cosine A attached through multiplication to this 1350, we cannot, no matter how much we want, combine those numbers. So what I'm going to do is get this cosine part by itself by subtracting 1354. And in doing that, so 676 minus 1354, we end up with negative 678 is equal to negative 1350 cosine A. I can now divide both sides by negative 1350. And in doing this, we've got negative 678 divided by negative 1350, 0.5022. So cosine A is equal to 0.5022. The inverse cosine of that angle is going to be 59.85 degrees. Okay, 59.85. Just like we did up above, I could use law signs to calculate the other two angles. I'm not going to do that for now. I'm going to move on to the next piece. So a gallon of quality paint costs about $40 and will cover approximately 300 square feet of canvas. How many gallons should the town buy for the artist's use? How much should they budget for paint? Okay, so if we know that 1 gallon is 300 square feet, I probably should figure out how many square feet this whole thing is. I could do this a couple ways. One would be to draw an altitude and figure out what that height is. I know what the base is. Another way I could do this is to say that area is equal to 1/2. We're looking at two sides, so 25 times 27 times the sine of the angle between them. That's 59.85. So 1/2 times 25 times 27 times sine 59.85, and we get that area is equal to 291.8 for, we were talking about feet there. This is feet here. That's about 300 square feet. So this makes sense if this would be about 1 gallon. So we're looking at about $40 of a budget. Next up, we got the unit circle trig section. We've got to convert things from degrees to radians, and not backwards on this side, backwards on the next side. To go from degrees to radians, we know we need pi, so I'm going to include that up top. So that'd be 21 multiplied by 2 pi divided by 360. I'm going to do some reducing, and I get 1 pi over 180. 21 is divisible by 3, so I can get this as 7 pi over 60, and that's about as far as I can go. For 1350, we do the same thing. 1350 times 2 pi over 180, and I might recognize that I could, 2 pi over 360, reduce that to 1 pi over 180. I can divide both of these by 10 to get 135 over 18. I'm going to rewrite this now, just so that I can see that a little bit more clearly. And then looking at this, I'm going to try to divide this further. If I try to divide by 3, we end up getting 45, and on the bottom we get 6. I can divide that by another 3, and I get 9 pi over 2. Going from radians to degrees, we're multiplying by 360 over 2 pi. Pi's cancel out. 360 over 3, I'm going to end up with 120 up top. I can divide that by 2 and end up with 60 on top. That leaves me with only 60 times 35, which is the same as 30 times 70, or 2100 degrees. 17 pi over 6 times 360 over 2 pi. Pi's cancel out. That's going to give me 180 over 1. 180 divided by 6 is going to be 30. 17 times 30 is 510 degrees. For the next part, I don't know why this is not labeled with numbers, but that's okay. We've got to find some coterminal angles, and we've got to do some sketching with reference angle. For 144, I'm going to do 144 plus 360 to give me my first reference angle, my first coterminal angle, and that's going to be 460, 500, 504 degrees. And then I'm going to do 144 minus 360 to find my other reference angle, which is going to be somewhere on the order of negative 216 degrees. I'm sorry, another coterminal angle. Sketching this, 144 degrees is past 90 but before 180. And my reference angle would be the angle that I need to get to 180. To get to 180 from 144, that's going to be 36 degrees reference angle. For 22 pi over 6, first thing I'll do is add 2 pi to this. Pi over 6 plus 2 pi, which is really 12 pi over 6 to get 2 when I reduce that. A positive reference angle would be 34 pi over 6, which could be rewritten as 17 pi over 3. In fact, this first guy could be rewritten as 11 pi over 3, and that might make our numbers a little bit nicer. Going the other way, we got 22 pi over 6 minus 2 pi, or minus 12 pi over 6, and that's going to be 10 pi over 6, but that's not a negative number, so we have to do this again because we're not in negatives yet. So 10 pi over 6 minus 12 pi over 6 is equal to negative 2 pi over 6, or negative pi over 3. That one we had to go twice because we didn't quite have enough to make that happen. 22 pi over 6, I'm just going to reduce this now to make our lives easier. It's going to be 11 pi over 3. Going around one full circle would be 6 pi over 3, because that's 2 pi. I'm going to go not quite all the way a second time around, because it's not quite 4 pi. I'm going to end down here. So if we're looking at not quite 4 pi minus 11 pi over 3, that's going to be 12 pi over 3 minus 11 pi over 3, which is 1 pi over 3. I'd like you to notice that this fraction is the same denominator as what we started with a fully reduced fraction. For the last part, these are talking about unit circle things. I'm looking at a 60-degree triangle in the first quadrant. Cosecant is going to be reciprocal of sine. So if sine would be root 3 over 2 over 1, I've got to take the reciprocal of root 3 over 2, and I get 2 over the square root of 3. If you wanted to write that with a rationalized denominator, that'd be 2 square roots of 3 over 3. Either one of those is an acceptable answer. For negative 5 pi over 4, well, first I got to figure out where that is. Negative 5 pi over 4, I know I'm going backwards. I know that this would be negative pi, and negative 5 pi is a more negative version, so we're going to keep going past this. This would be negative 3 pi over 2, which is the same as negative 6 pi over 4. So I'm not quite going that negative. We're looking at this quadrant. You might recognize this in the pi over 4 family. So my coordinates here would be negative square root of 2 over 2, common the square root of 2 over 2. Since cosine is the x value, my answer would be negative the square root of 2 over 2.